Welcome to qnawire.
All right, let's go ahead and start solving this problem. So we're given a field vector f, which is x squared y, comma x cubed over 3, comma xy. C is the curve, which is the boundary of the intersection of x squared plus y squared equals to 1. That's a cylinder. And z is equal to y squared minus x squared. That's I believe it's a hyperbolic paraboloid or whatever it is that it's called. It's not a really nice shape that's easy to visualize. So you can either draw a bunch of contour diagrams to try to visualize it, or you can just use an application such as GeoGebra in order to graph it and see what it's going to look like. So using Stokes Theorem, we're simply going to evaluate the expression, the double integral s curl f dot ds. So we're going to try to evaluate this thing. So first, let's figure out what the curl is. This will end up being x comma negative y comma 0. Okay, now let's parameterize the surface S. I choose to use a polar coordinate system. So let's say that this is rho cosine theta. I use rho instead of r because we know we're using r here already. I don't want to confuse anyone. The y is going to be rho sine theta. And because z is equal to y squared minus x squared from this expression right here, we know that it can be rewritten like this. Z is equal to rho squared sine squared theta minus rho squared cosine squared theta. You can factor out a rho squared, and if you recall, cosine squared minus sine squared is equal to cosine of 2 theta, so this is the negative version of that. So we can rewrite it as negative rho squared cosine of 2 theta, and I will choose that as my expression of z. Okay, now we want to find a normal vector, so we are going to take the derivative with respect to rho and theta respectively. For rho, you will get cosine theta sine theta negative 2 rho cosine 2 theta. With respect to theta, it is going to look like negative rho sine theta, rho cosine theta, comma 2 rho squared sine of 2 theta. Now let's take the cross product. Rho cross theta. Okay, now when you find the cross product straightforwardly, you should get an expression that looks like this. 2 rho squared sine theta sine of 2 theta plus 2 rho squared cosine theta cosine of 2 theta. And that's just for the x entry or the I vector. So you might think that this is a really ugly expression and it's going to be a tough one. Whenever things like this happen, I want you to first think that there actually might be a good expression for this thing. The biggest hint is that you have a 2 rho squared in there that's common. And trigonometry, when you combine things with other angles, oftentimes they end up being a simpler expression. And of course, because that's due to the flexibility of trigonometry. So one thing that you might want to consider is to graph things such as sine theta sine of 2 theta plus cosine theta cosine of 2 theta and see what it looks like on a graph. And if it looks simple, then maybe it's actually an indication that it's going to be a simpler expression. Okay, so just to go through the idea, We know that sine of 2 theta is 2 sine theta cosine theta. And cosine of 2 theta, because I know over here that you will get sine squares, I'm going to try to express cosine of 2 theta as 1 minus 2 sine squared. When you do that, you can see that it simplifies significantly, and it just turns out that this is equal to cosine theta. Okay, so using this idea, this expression right here is simply equal to 2 rho squared cosine theta. Okay, the the j vector, the y part, this portion is also going to have an ugly expression, but it simplifies in a very similar way. So you will get negative 2 rho squared sine theta. This part, I want you to confirm it on your own. And the last expression is just rho. Okay, let me move this over here. All right, so we want to express now the curl with respect to rho and theta. It is simply rho cosine theta negative rho sine theta, comma 0. Now when we take curl f dot the cross product, we will get 2 rho squared. So the expression that we're trying to evaluate is basically 2 rho squared through ds, and we simply used rho and theta as our parameters, so it'll be from 0 to 2 pi. And z changes from, I believe it was from 0 to 1, because that's the rho value. 2 rho squared. Oh, no, it's not 2 rho squared, it's 2 rho cubed, because it's a polar coordinate system. So d rho d theta. And then when we evaluate this expression, we will end up having pi. And this is how you solve this problem.